Let me ask you something simple. When did you last feel genuinely thirsty? Not thirsty because you just finished exercising. Not thirsty because you ate something salty. Just spontaneously, undeniably thirsty. The way you felt when you were 30 or 35. If you're over 50 and you think about it honestly, you probably can't remember. And that is one of the most dangerous things happening inside your body right now. Because here is what the research has established beyond any reasonable doubt. After 50, the biological mechanism that tells you when your body needs water begins to fail. The osmoreceptors in your hypothalamus, the sensors that detect rising fluid concentration in your blood, become progressively less sensitive with age. By the time you're 60 or 65, your thirst signal may be functioning at a fraction of its former efficiency. What this means in practice is terrifying in its simplicity. You can be significantly dehydrated, your blood concentration elevated, your cellular fluid levels critically low, and feel absolutely nothing unusual. No dry mouth, no thirst, no obvious signal. Just the quiet, invisible consequences of chronic mild dehydration accumulating day after day. And those consequences, inside your brain specifically, are now among the most documented and alarming findings in cognitive aging research. A study from the University of East London found that even mild dehydration caused measurable impairment in attention and short-term memory. That is a fluid deficit of just 1 to 2% of body weight, an amount that produces no thirst in most adults over 50. A deficit you could accumulate simply by breathing, sweating slightly, and forgetting to drink during a busy morning. And chronic mild dehydration produces consequences that go far beyond temporary cognitive impairment. By the end of this video, you are going to understand exactly what those consequences are and why water alone is often insufficient. We will also cover the research-supported morning hydration protocol for adults over 50. This is simpler than almost anything else we've covered, but it may have the most immediate impact on how you feel. Your brain is approximately 75% water. Not a metaphor, not an approximation. 3/4 of the tissue sitting inside your skull is water, and that water is not simply filler. It is structurally and functionally essential to virtually every process your brain performs. Water maintains the precise ionic concentrations, sodium, potassium, magnesium, calcium, that neurons require to generate and transmit electrical signals. Water is the medium through which neurotransmitters diffuse across synapses. Water is the primary component of cerebrospinal fluid that bathes the brain. It cushions it from mechanical shock and, critically, serves as the medium for glymphatic waste clearance during sleep. When brain water content decreases, even modestly, these processes are disrupted at every level simultaneously. A study published in Neuroradiology used MRI to measure brain volume across hydration states. The findings were striking. Even mild dehydration produced measurable reductions in brain volume. The brain literally shrinks when dehydrated. The regions that showed the greatest volume reduction were the hippocampus and the prefrontal cortex, critical for memory and executive function. The brain rehydrates when fluid is restored. But for adults who are chronically mildly dehydrated, this shrinkage is a persistent state. Their brain is operating at reduced volume essentially continuously. The cognitive consequences are well documented. Attention was the most sensitive, showing decline at 1% dehydration. Short-term memory and processing speed also showed significant decline. Now here is the connection to the glymphatic system. Cerebrospinal fluid is primarily water. The flow of fluid through glymphatic channels depends on adequate volume. When you are chronically dehydrated, this flow is impaired. The overnight clearance of amyloid beta and tau proteins associated with Alzheimer's is less complete. Night after night of dehydrated sleep leads to reduced glymphatic clearance. The waste that doesn't get cleared accumulates. When blood becomes more concentrated due to dehydration, blood viscosity increases. Thicker blood flows less efficiently through fine vessels. The reduced cerebral blood flow directly impairs neural function and amplifies the damage from arterial stiffening. Arterial stiffness and dehydration-driven viscosity compound each other, producing greater cerebral blood flow reduction than either alone. Let's understand the thirst mechanism failure in detail, because this is the key insight that makes everything else in this video make sense. Your body regulates fluid balance through a system centered in the hypothalamus. Specialized neurons called osmoreceptors continuously monitor the concentration of solutes in the blood, essentially measuring how much water is present. When blood concentration rises, when you lose fluid through sweating, breathing, or urination, osmoreceptors detect the increase and trigger two responses. They signal to the pituitary gland to release antidiuretic hormone, which tells the kidneys to conserve water, and they trigger the conscious sensation of thirst, the uncomfortable dryness and craving for fluid that motivates you to drink. In a young, healthy hypothalamus, this system is exquisitely sensitive. Even a 1% rise in blood osmolality triggers a clear thirst signal. The system is proactive, maintaining fluid balance before a deficit becomes problematic. Research in the European Journal of Clinical Nutrition found a consistent, significant decline in sensitivity beginning in the 50s. By age 65, the average osmoreceptor sensitivity has declined to the point where blood osmolality may need to rise by 2 to 3%. This represents a meaningful fluid deficit before any conscious thirst sensation is triggered. This is a fundamental breakdown in the body's primary fluid regulatory system, and the consequences extend beyond simple dehydration. Hypothalamic aging also reduces the kidney's ability to concentrate urine efficiently, meaning older adults lose more water for the same fluid intake. Older adults also have proportionally less total body water than younger adults, meaning any deficit represents a larger percentage dehydration. The result is a perfect storm. Older adults need more careful attention to hydration. They have less margin for error. They have a less reliable internal warning system. And they have reduced capacity to compensate for fluid deficits when they occur. This is why hydration in adults over 50 cannot be managed by thirst alone. The thirst signal has been broken. A deliberate, proactive hydration strategy, one that does not rely on feeling thirsty, is not optional. It is a biological necessity. Now let's talk about why water alone is often not sufficient to restore true cellular hydration, because this is the part that most people and most mainstream hydration advice completely misses. Here is something that challenges the most basic assumption most people have about hydration. Drinking water hydrates you, that's obvious, but the relationship between drinking water and actual cellular hydration, and the water content inside your cells, is not as direct as most assume. Water moves into and out of cells through a process governed primarily by osmotic gradients. The balance of electrolytes inside and outside cells determines how much water enters the cells and how much remains in the extracellular space. The most important electrolytes are sodium, which regulates extracellular fluid, and potassium, which primarily regulates intracellular fluid. When the sodium-potassium balance is optimal, water distributes efficiently between the extracellular and intracellular compartments. When it is disrupted, water may be present in the body in adequate quantities, but fail to enter cells efficiently. Now here's the problem for adults over 50. After decades of typical Western dietary patterns, most have a significant sodium-potassium imbalance. The sodium-potassium ATPase pump, the mechanism driving potassium in and sodium out, becomes less efficient with age. The result is that many adults over 50 who drink adequate water are still experiencing cellular dehydration. Water pools in the extracellular space and is excreted by the kidneys, leaving the brain cells in a state of relative dehydration. Simply drinking more water without addressing electrolyte balance is often insufficient to resolve chronic cellular dehydration that drives cognitive impairment. Research found that hydration solutions with specific ratios of sodium, potassium, and magnesium produced significantly better cellular hydration than plain water. The second key compound is magnesium. It plays a critical role in the sodium-potassium ATPase pump function. When magnesium is adequate, the pump functions efficiently. When it is deficient, pump efficiency declines and cellular hydration suffers. Our magnesium protocols, L-threonate in the morning and glycinate in the evening, are doing double duty. They support brain synaptic function and the cellular hydration machinery that the brain depends on for basic function. Now let's make this completely practical, because this is one of the simplest protocols in the entire series, and it is one that can produce noticeable benefits within days rather than weeks. The 2-minute morning fix is built on a single core insight. The period of greatest dehydration in the 24-hour cycle is the morning, specifically immediately upon waking. You have been breathing, sweating slightly, and losing water through normal metabolic processes for 7 to 8 hours without any fluid replacement. Your blood osmolality is at its daily peak. Your brain is at its most dehydrated point of the day. And because your thirst signal is unreliable, you may feel nothing unusual. You get up, make coffee, and begin your day. You start in a state of meaningful fluid deficit that you are completely unaware of. The morning fix addresses this directly. Within the first 5 minutes of waking, before coffee or food, You consume a specific hydration solution that rapidly restores fluid balance. It delivers electrolytes needed for cellular water distribution and primes your brain for optimal function for the rest of the morning. Here is the exact formula that the research supports. 500 milliliters of room temperature water, approximately 16 ounces or 2 standard glasses. Room temperature rather than cold, because research shows room temperature water is absorbed more rapidly from the gastrointestinal tract than cold water. Added to that water, a quarter teaspoon of high-quality sea salt or pink Himalayan salt, providing approximately 500 milligrams of sodium. This sounds counterintuitive, adding salt to your morning water. But this modest sodium addition serves a specific purpose. It triggers the sodium-potassium ATPase pump and creates the osmotic gradient that draws water into cells rather than passing to the kidneys. Also added, a quarter teaspoon of cream of tartar, which is pure potassium bitartrate, providing approximately 500 milligrams of potassium. This is the most affordable and most bioavailable potassium source available in most kitchens. Potassium is the primary intracellular electrolyte. Most adults over 50 are significantly potassium insufficient, consuming far less than the recommended 3,500 to 4,700 milligrams per day. Optional but research-supported addition, a squeeze of fresh lemon juice, providing citrate to improve mineral bioavailability and support kidney function. Total preparation time, approximately 2 minutes. Total cost per day, less than $0.20. These are staple pantry items. Consume this solution immediately upon waking, before coffee. Caffeine is a mild diuretic. It increases hydration may be the simplest topic we've covered in this series, but I want to make the case that it may also be the most immediately impactful, for a specific reason. Every biological process, every repair pathway, every cellular function operates in a water-based medium. There is no biological chemistry without water. Every enzyme reaction, every neurotransmitter diffusion, every ion channel opening, every mitochondrial process, all of it happens in aqueous solution. When that solution is even mildly depleted, everything runs slightly worse. The BDNF signaling from video 1 is less efficiently distributed. The magnesium ions from video 2 diffuse less effectively across synapses. The liver detoxification from video 3 runs on reduced fluid throughput. The mitochondrial processes from video 4 are less efficient. The glymphatic clearance from video 5 is directly impaired by reduced cerebrospinal fluid volume. The gut epithelial cells from video 6 function less well. The hormonal transport from video 7 operates through a thickened, more concentrated blood medium. Adequate hydration is not a separate mechanism. It is the medium in which the entire system operates. Optimizing it removes a hidden drag. You are following sleep, exercise, and social protocols. But it may be running in a medium that is 5 to 10% depleted. 2 minutes every morning. A quarter teaspoon of salt, a quarter teaspoon of cream of tartar, 500 milliliters of water. Tonight, place a large glass of water on your bedside table. Add a small container of sea salt and cream of tartar next to it. When you wake up tomorrow morning, before coffee, before checking your phone, prepare and consume your morning electrolyte solution. Notice how your morning mental clarity changes. Notice whether the cognitive fog that many people accept as normal begins to lift. Set 2 phone reminders, one at 10 a.m. and one at 2 p.m. Do not rely on thirst. Your thirst signal is not reliable after 50. Next week, we are going into autophagy, the cellular self-cleaning process your body uses to clear damaged proteins and dysfunctional mitochondria. Research shows autophagy declines after 50. We'll discuss practices that can powerfully reactivate it. Subscribe now and share this video. Thank you for 12 videos. Stay sharp, stay hydrated, stay vital. I will see you next week.